Okay, one of the things that we're trying to accomplish in the first lab is to get you an idea of how the workflow goes with using a tool called Vivado. So Vivado is the way that we are able to take a description of hardware in Verilog. So Verilog is a hardware description language. So we describe the hardware. We even figure out ways to simulate that hardware, but eventually you want to have the hardware programmed in an FPGA. FPGA stands for Field Programmable Gate Array. So you want to be able to program the hardware to show up on your hardware target. So for this class, the hardware target is the Basys 3 boards that we'll end up showing at the end of the video. Okay, or at least showing that that's where we end up. Okay, so I want you to think of it in terms of the big picture. You're not going to understand every detail, but that's the problem with Lab 1 is you get in there and you start using Vivado and you have to do the next step. And the next step is pretty detailed because you have to find some files on your computer. You have to upload those files to Vivado. You're just running the workflow. And what I want you to think about is the big picture. And that's what this graphic is about. So the first thing that you're going to need to do is you're going to need to create the project. So when you run Vivado, that's the first option that it gives you, and you have to decide where to create the project. And the big takeaway initially is do not create the project inside the same folder as your code repository. Okay, that needs to be outside because you don't want to create a project that you push with GitHub all the way up to your code repository. So keep that out of your code repository. That's the key step on creating the project. So from there, you've created the project and Vivado is going to ask you a few questions and you have to add some files. Okay, so along the way, your code, maybe you have a counter, maybe you have a top module, you'll have design sources that are part of your Verilog code. And you'll also have some simulation sources. And then this third category down here, constraints, this is the file that tells you how to connect different parts to the FPGA boards down here at the ultimate goal. How do you create the added parts that you need to make everything work? Okay, so you don't need to know all the details about these things. Concentrate on the flow. So the first thing is you add RTL. Okay, so we created the project, then we add RTL. Okay, so RTL means, from the previous video, these are like design sources. All right, it says right there, design sources. So we've now added those to the project. Sometimes we are just doing a hardware target. If you're just doing a hardware target, you don't actually need to add test benches. But in this case, let's do the full workflow. We add test benches. Okay, once we've added those, we need to add constraint files. So I hit this button here and I add the constraint files to tell what the connections need to be on the board. From there, we can actually start doing work. Okay, so this is the design flow. This is the part, these first four things are what you do to create a project and add the different components to it. Okay, so from there, you run the simulation. Hopefully everything runs and looks the way you want. And then you need to try to make this fit onto the board. And that's a multi-step process. There's a synthesis step that you have to run. It converts the RTL to a gate level netlist. That means nothing to you now. And it's not a super important part of the course, but it has to do some things. This takes a while. The Vivado workflow is slow because it has to do a lot of things. So that's why you don't want to, when you make edits to your code, you want to be careful and not just recompile all the time because it takes a long time to do it. All right, so from there, you run the implementation. Hopefully that runs clear. Then you have to generate a bitstream. Okay, I think of the bitstream as a file that's created that tells what all the connections need to be to make the hardware implemented on the FPGA. All right, and then from there, you will pull up a hardware manager. You can program the board and everything should be up and running. So if you go through this and play with this this diagram, all right, you can click on things and see what the output files are that get generated, but that's not super important at this step. The important thing is create a project, add the design files, add the test benches, add constraints, run the simulation, run the synthesis, run the implementation, generate the bit stream, program the board, and you get the outputs that you need. I wish it ran that fast, but that's the process. And you're going to do this probably dozens and dozens of times. So you'll work through it. And what I want you to do is think about what's going on so it can work to your benefit as you go through the course.